page are those?
That's on page 104. This isn't the best setup in the world, but we're just going to try and make it work. We took a little break on Friday and we practiced graphing linear equations again.
What's today, Mr. Mackey?
Sorry?
What's today?
The 29th.
It's the 28th.
28. Okay, a piecewise function. There are many reasons for piecewise functions. And basically it's, if something fits this, then here's how you do it. If it fits something else, then you use this formula. If you're thinking about going to work somewhere when you start off, they have one way to calculate your pay. If you're in a beginning position, for all the time that you're in that beginning position, here's how they're going to pay you. Here's how it will increase as time goes by. However, if you get more training, if you, for some reason, get promoted to a different level, then the way that they do your pay all of a sudden is going to be different. You're not on that beginning level anymore. Now here's how we're going to calculate your pay. And then if you really get good at something, if you really get trained, you really get prepared to do an even higher level job, then all of a sudden, here's how we're going to pay you, and here's how your pay will increase over time. That's just one example of why you would use piecewise functions. A company that produces product, maybe they have different machines that they use based on the amount of product they need to produce. If some small company orders from them, it may be more economical for them to use this one machine. And here's how this machine works producing the goods over time. However, if somebody places a larger order with them, a larger company, it may not be efficient to use that smaller machine anymore. Maybe they move up to the next largest machine, or maybe they use two machines at the same time. And here's how producing the product increases over time using two machines or using a bigger machine. So piecewise functions do have valid reasons for being in existence. In number 2, you have 3 different functions. 8, 2x, and negative 4 minus x. So if we were going to graph each of those, each of them would make an independent line on their own. The graph of f of x equals 8, what would that line look like? Be a perfectly horizontal line where y equals 8. So up here at the tippy top, y equals 8. So here's the line, f of x equals 8. The function f of x equals 2x. If you'll notice, there's nothing being added or subtracted out to the end of this. So the y-intercept must be 0. So you would start at 0, and then you would go up 2 over 1. There's your next point. And here is that particular line. F of x equals 2x. And then finally, the function f of x equals negative 4 minus x. That can be rewritten as negative x minus 4, just to make it a little bit more understandable. Because now we have it in slope, intercept form. Here's our y-intercept. 1, 2, 3, 4. Here's our slope, negative 1, which means go down 1 and over 1. So down 1, over 1, draw the line. F of x equals negative 4 minus x. Any questions so far? So if you had to draw or plot 4 lines on a coordinate system, there's no doubt in my mind you could do that. That's what we've done right here. 3 lines on a coordinate system. The next part is going to tell us what part of the graph that we need to keep for each of these individual lines. The first restriction, if you will, or condition to meet is for the first line. We only want the part of it that has x's that are less than or equal to negative 1. Well, here's negative 1 for the x's. I'll follow that all the way up to this line right here. That means that everything that comes before it needs to be gone. I'm sorry, it comes after that. It needs to be gone because less than goes to the left. And would there be a solid dot here or an open dot?
No.
Solid dot. So here is our first line given that restriction. For you, draw these lines and now you go and you erase everything that comes after where x is negative 1. The second restriction on the second function is if negative 1 is less than x, which is less than 4. And what this means is you want to keep everything from where x is negative 1 to where x is positive 4. Here's where x is negative 1. 1, 2, 3, 4. Here's where x is positive 4. There's no equal sign with either of those, so we want an open dot and an open dot. And we're going to get rid of everything that's outside the bounds of those open dots. So this means keep everything in between and nothing on the outside of it. So here we go. So now we got this ray here, and we got this open-ended line segment. And we only have one more restriction to place, and that's on the last function. If x greater than or equal to 4. Here's where x equals 4. So we follow it all the way down to the line that we drew. There's an equal part with it, so we make a solid dot, and we erase everything that came before it. So just to draw the picture a little bit clearer, here's what your graph should look like. Okay. 8th period already got these. I don't think I gave them to you. And I'm ready for an election or something. What are we going to take this math today?
Don't jinx it though.
It's going to happen whether I talk about it or not.
Whoa, 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 whoa. Please tell me we're doing this together.
What? Piecewise functions. You can either psych yourself out about them and say, I just don't understand it, I don't like it, I'm not going to do it. Or you can just jump in there and learn it and figure out it's not nearly as difficult as I thought it would be. One of the things that I don't like about the book, all the math books that we have and every math book that they give us today, is all the different forms that they try to throw at you all at once. And you're probably looking at this and saying, well, what are you doing to me? This is actually a lot simpler than what we would get out of the book, and it gives us practice at the skill, at the principle, rather than trying to disseminate some English paragraph. Alright, here's how this works. In the first part of it, it says evaluate the function for the given value of x. So they give us 3 different piecewise functions. The first one is named f, the second one is named g, and the last one is named h. And they were nice to us because 1, 2, 3, and 4 all use the function named f. 5, 6, 7, and 8 all use the function named g, so they didn't mix them all up. And what you're going to do is you're going to look for the proper function, take the input value they give you, and then determine which one of these do you use. You'll only use one of them. Number 1, f of 2. Well, is that input value less than or equal to 0? 2 is not less than or equal to 0. 2 is greater than 0, so here's the function that we'll use, and the answer is just simply 2. It's going to be pretty easy on 1 through 4. Your answers are either going to be 3 or 2 based on the input value they give you. When you get to number 5, there's actually some calculation that has to be done. So look at number 5, g of 7. So we're using this function. Our input value is 7. So we check against the first condition. Is 7 less than or equal to 3? No. Is 7 greater than 3? Yes. So here's the function that we will use. We will input a 7 where the x is. So it's 2 times 7 minus 1 equals 13. Likewise on number 9, h of negative 4. That means we'll be using the function named h, and our input value is -4. Is -4 less than or equal to -2?
Yes.
Yes. So this is the function that we'll use. 1/2 times -4 minus 4. Okay, so you feel like you could do 1 through 12? You only have 9. Yeah. Take a few minutes to do those, and then we'll talk about what this beautifulness is. Oh. For this next part, it's matching. Match the piecewise function with its graph. You may have to, in your calculator, graph these lines to remind you what they look like. Let's see here. Now this one right here, it's got a y-intercept of -4, and the slope is 1. So up 1 over 1 from -4. Positive slope. Positive slope goes this way, negative slope goes that way. I want to see one function with a negative slope. That's this one right here. So which graph shows a negative slope? Hey, that kind of solves that one just from the start.
Wait, what?
There's only one of these graphs that have a line with a negative slope. Positive slope goes that way, negative goes that way. There's only one function with a negative slope, it's this one right here. So this one belongs to number 18. Now the scale on these graphs is 2. You're counting by 2s. 2, 4, 6, 8. 2, -2. So right in between 0 and -2 is -1, which is that y-intercept right there. On B, both my lines have a y-intercept that's +4. It's 14. So let's see if you can figure out the other 4. Okay, and finally, 19 through 21. Graph the function. Here's what I would do. I'd forget about the restriction part first, and just graph the two lines. Then I'd go back and I would look to see, all right, where is it that I'm supposed to split them up? Where does one stop and the other start? And I would erase the part that doesn't belong for each line. I'm working in pen. I mean, I could graph the lines, but I can't erase. If I did it in pencil, the people watching the video wouldn't be able to see it. So